Ahoy, you salty sailors. Time to raise anchor and set sail for your best scrawny life. Arr!
We're going to discuss 3 species of plants in the family Anacardiaceae, the sumac family. This family has over 80 genera. Among those is genus Rhus and genus Toxicodendron. Each of those genera have around 30 species. Within the genus Rhus, the 2 species we'll be concerned with today are Rhus aromatica, Fragrant Sumac, and Rhus typhina, staghorn sumac. And the Toxicodendron species we are concerned with today is, of course, our old friend, the eastern poison ivy. Even though Fragrant Sumac very much resembles poison ivy and looks quite different than Rhus typhina, the staghorn sumac, you might wonder how can it possibly be a sumac without that long pinnately compound leaf we're so familiar with. But the fragrant sumac does have a compound leaf. It's just a trifoliate compound leaf, like poison ivy, rather than that very large pinnately compound oppositely arranged leaf. Now poison ivy, the central leaflet, has a separate stem that extends beyond the other 2 a little bit, which Rhus aromatica does not. The berries of Rhus aromatica are edible. They're used to make a drink like lemonade. Yeah, I'll occasionally pick one and munch on it, spit out the seed. It does taste a little bit like lemonade. It does have a nice smell to it. So fragrant sumac, it's an interesting plant. Dioecious, the flowers come out very early in like March or something. There are usually male plants and female plants. Now, something else that has a pinnately compound leaf is our old friend Xanthosxylum americanum, the toothache tree. And that does also grow in those riparian areas, many of the similar areas. So there's Rhus aromatica, there's Xanthosxylum americanum, growing right next to it. And just down the way, there's some staghorn sumac, Rhus typhina, for a little idea of how those are all different. There. Rhus aromatica, and then right next to it is Toxicodendron radicans, poison ivy. There's another look at staghorn sumac. That's what Rhus aromatica is all about. So I found a mushroom, and I think it is possibly one of these 2. Now on the left we have Lactarius uvidus, and you'll notice the color of the caps between the 2 very similar, but Lactarius uvidus has some concentric zoning, some rings of slightly varying color that go around the cap, whereas Lactarius fumosus does not have the concentric zoning. Both of these mushrooms develop a stain, but it takes quite a bit of time. It takes a half hour at least. So in this case, both mushrooms, when they are damaged, will produce a white latex. The differences only appear about half an hour later when the latex begins to dry, and in Lactarius uvidus, we begin to see that it dries and creates a purple stain. And in Lactarius fumosus, we see it produces a rusty brown stain. And the spore print is also kind of a beige to somewhat rusty brown color. So after carefully considering the mushroom I found, I decided that this may in fact be a 3rd possibility, Lactarius argillaceifolius. You'll notice it has somewhat of a tendency to form lobes around the margin of the cap, and there are some lilac tones in the top of the cap, very faint. After I scratched it, there wasn't a whole lot of latex that came out, but there was some. And I returned about half an hour later, but the latex had not really dried out enough to change color or create a stain. But due to those slight lilac tones and the slight tendency to create lobes, plus the lack of concentric zoning, I decided to call it, I decided that it was leaning more towards Lactarius argillaceifolius. So here we are with the Asclepias purpurescens, the purple milkweed, and you can see the flowers and the leaves as well are slightly different than the common milkweed. A little bit more red overall in both of them. It seemed to attract, and there's some yarrow next to it on the right in that photo. We'll get to that in a second. It seemed to attract this species of butterfly, which turns out to be something called the Great Spangled Fritillary. So there's a name and a half for you. So, and here we have a Latoporus cincinnatus. Remember in the previous, or 2 videos prior to this one, that we found one of those emerging from the fallen stump of an oak tree, and this one emerging around the base of a still standing live oak tree. Now here we are with yarrow. You'll notice the very finely divided fern-like leaves. Now it does produce somewhat of an umbel, but this plant is actually in the family Asteraceae, the composite flower family, not in the family Apiaceae, the parsley family. So it is not closely related to something, say, like hemlock, like poison hemlock. So here we see some mayapple plants in the forest, and they are blighted with a fungal pathogen called mayapple rust. If I were to turn over one of the leaves, we would see a small cup-like fungus that would probably be producing some spores, but I didn't want to get it on myself and spread it all over the forest. So here we have one of the grisette amanitas. I do know the full Latin binomial for this mushroom, but it's one of those names that you just kind of wonder why taxonomists would name a mushroom such a thing. So we're not going to use its true Latin binomial. You'll notice that the stem of this, although it is an amanita, does not have a ring or an annulus. There's no annulus. It does have some rough sort of scaly material on the stem, but no annulus. And here, of course, we have the ox-eye daisy. Now there's another one where the name just doesn't seem to make any sense. If you own an ox and its eye looks anything like this flower, then I recommend you call the vet, because that is not normal. However, the common name is ox-eye daisy for whatever reason, and of course it's not to be confused with daisy fleabane, which is this plant here, somewhat more common here in Iowa than the ox-eye daisy. These are, of course, members of the family Asteraceae, the composite flower family. And in just a moment, we'll look at Lactuca floridana, which is another Asteraceae. So as we approach midsummer here, the Asteraceae beginning to dominate the flowering plants and forests. So we did get a fruiting of Boletus variopes. Most of the ones I found in that area were past their prime and pretty much completely eaten by bugs, but this one was pretty good. You'll notice that somewhat velvety, somewhat felty texture to the cap, and then this reticulation pattern on the stem. There they've girdled a couple of hickory trees, and we had some Boletus variope emerging around them. But as I said, most of them were well past their prime. In this one you can see it's actually been up for long enough to dry out, and the cap has become cracked. And you'll notice that the tube layer, the spore-producing layer of the mushroom, has turned yellow, whereas in the fresh one it was more of a white color. So that's one of the rosette grasses. Not exactly sure which species. Of course, here we have some ferns growing in the shade of the large oak trees near a stream. More ferns. Ferns are an indication that you're in a good area for mushrooms, but of course this plant, which is commonly known as wood betony, and there we're back to the rosette grasses. We got a red oak there, but here we are again with the wood betony. That plant is a direct indication that fungal mycelium are active in the soil underground, because it's a hemiparasite. It produces some photosynthesis on some of its own food via photosynthesis, but it also parasitizes other plants via the fungal mycelial network underground. Which makes sense because it generally grows in some of the darkest parts of the forest, where there isn't much light penetration. So it is a hemiparasite, photosynthesizing some of its own food, but stealing some of its food as well. The flowers, I never seem to quite catch it in bloom, but the flowers kind of spiral around like you see in these photos. So, we got a mushroom. What could it be? It's another amanita. Here we can see, well, we can't see well because the lighting is washing out the light colors of the mushroom cap. This is possibly Amanita citrina, but you can see those fleshy warts, which are remnants of the partial veil that covered the mushroom when it was young. And then on the underside there is a vulva or bulge on the base of the mushroom, and then about halfway up the stem or stipe is the annulus. And of course, snacking on the gills there is a large slug. So here's another specimen of that same species, possibly Amanita citrina. Notice the warts left behind by the partial veil, or the universal veil, I mean. So we have a fallen hickory log, and on it we've got some wood ears. These will dry out and almost completely dehydrate during dry spells, and then soften up and moisten up again. We've had some rain here recently, and they have rehydrated and thus have become floppy and squiggly again. That is an edible mushroom, not much flavor to it. Here we have Florida lettuce. I think that's what it is, just based on that terminal lobe of the leaf, based on the size of that. I think it probably is Lactarius floridana. There's some more of it. Not all the plants were the size of that one. You can see that terminal lobe is generally larger than the other lobes. And here we have Coprinopsis variegata. Wouldn't be June in Iowa without a good flush of that. It is one of the Satharalaceae, the ink cap, which contains the ink cap mushrooms, and you can see that the older caps are beginning to deliquesce around the margins. It's such a rich soil in terms of organic matter that you'll see some, in this case, emerging from the wood itself and some through the ground.